Continuing with 7.2, and we're on example 4. Write an equation of a line tangent to the graph of f of x equals 2x minus e to the x over 2 at this particular point. Okay, the equation of the line needs a point and a slope. And we can get the slope by taking the derivative of this function. Derivative of 2x is 2. This is a 1/2. So we're going to make it 1/2 in front. The derivative of e to the x is e to the x times the derivative of x is 1. And I need to evaluate this at x equals 0. So I get 2 minus 1/2. That would be 3/2, and that's my slope. So now I can write my equation. Y minus the y value equals m, the slope, x minus the x value. So y is equal to 3/2 x minus 1/2. And this was part A. So there's my equation. Part B, find the points on the graph where the tangent line is horizontal. Well, if the tangent line is horizontal, that means its slope must be 0. So I want all the places where this is equal to 0. Now, trying to solve this, I could subtract the, I'm going to move it around like this. 1/2 e to the x equals 2. I'm going to multiply through by a 2. So that's the question. How do you get rid of an e to the x? You put a natural log through the question. So you get x equals the natural log of 4. So there is a horizontal tangent at natural log of 4, comma, f of the natural log of 4. If you go back to the original, remember this is the original, to get the points on the curve, and put it in your calculator, this is, well, I want all decimals, I guess, 1.39, and this is 0.77. So there's the point where there's a horizontal tangent. Example 5. This one wants us to integrate e to the x over 1 plus e to the x dx. Okay, this is a u to u. I'm going to pick the most complicated piece for my u, because that's typically what happens. And then my derivative of 1 is 0, derivative of e to the x is e to the x dx. So now if you match up the pieces here, this turns into a 1 over u du, which is the natural log of u, plus some constant. We don't know what the constant could be, so we're going to put c because this is an indefinite integral. And then you have to go back and take out the u and put back what u was equal to. And since 1 plus e to the x will always be positive, I don't need the absolute value bars on it. On to number 6. Oh, now we're going to arc length. So remember, arc length is the one that has that square root in it. And you have to have the derivative of the function to work with it. And the interval is 0 to natural log of 2. So the first thing I'm going to do is I'm going to get the derivative. The derivative of 2 e to the x is 2 e to the x. The derivative of 1/8 e to the negative x would be negative 1/8 e to the negative x, because that derivative of negative x is a negative 1. And then I'm supposed to square this to put it in the formula. If I square this out, let me write it down. I will get 4 e to the 2x, put the 2 together, that's a negative 1/4 e to the 0, so negative 1/4, double it, negative 1/2, and then square the last term, 1 over 64 e to the negative 2x. Now remember your formula for arc length, 0 to the natural log of 2 is the square root of 1 plus the derivative squared. Never make the line long enough. If I collect my like terms here, I get the square root of 4e to the 2x plus 1/2 plus 1 over 64 e to the negative 2x. This factors, oops, I forgot my dx. And it factors to 2e to the x plus 1/8 e to the negative x, quantity squared, which then pulls it out of the square root. So I have 2e to the x plus 1/8 e to the negative x dx. And I integrate that. The integral of 2e to the x is 2e to the x. However, the integral of 1/8 e to the negative x, don't forget you have to stick a negative in front, because that would be your du is a negative 1, because my u would be negative x, so this becomes negative 1/8 e to the negative x. Now, if you ever get stuck and you're not sure you're right, just take this guy's derivative and it should match what you had with the integral. And we're evaluating this from 0 to the natural log of 2. So I get 2e to the natural log of 2 minus 1/8 e to the negative natural log of 2 minus 2e to the 0 minus 1/8 e to the 0. This is going to give me e to the natural log of 2. The e and the natural log will wipe out because they're inverses of each other, and you just have the 2 left. So I'm going to get 4 here. And then this negative in front of the natural log should be raised to an exponent, so that'd be 2 to the negative 1. I'm looking at this piece right here. The e and the ln would cancel, so I'd get negative 1/8 times 1/2 minus e to the 0 is 1, so 2 minus 1/8. 4 minus 1/16. 2 minus an 8 would be 15/8, but plus, no minus. And if I add all this together, that is 64 over 16 minus 1 over 16 minus 30 over 16, 33 over 16. And that's that answer.